Tensors are introduced in physics and mathematics, but in neural networks and in TensorFlow library it is completely different. Basically, it is multidimensional arrays of different types, and it is also designed for hardware acceleration, so neural network can do all maths in short time. And in this lecture, we are going to see how to build tensors of different shapes and what are the operations we can do on tensors. So first, we must learn how to create tensors. Here, I am going to use constant function from TensorFlow library to create tensors, and I am just passing a single element to create rank 0 tensor, and in output you can see data type is automatically decided, and here shape is 0 because a single element does not have any dimension. If you want to create rank 1 tensors, you need to pass a list of values. Here I am passing float values, so it will that type is going to be float automatically, and shape is 3 because I have given 3 elements in constant function. And by seeing shape we can see dimension is 1 because length of shape is 1 and that shape have 3 elements. And to create rank 2 tensors or a matrix, we need to pass rows and column in constant function. For example, I'm creating 3 by 2 matrix, so I have to create 3 rows. One row have 1 and 2 element, second row have 3 and 4 element, and third row have 5 and 6 element. Each row have 2 column. So you can see in output 3 by 2 tensor has been created, and data type is integer type. If you want to specify a different data type, you can pass given 2 data type parameter, and here I am saying I want to create float data type. So I am passing df.float64. Now you can see float64 that type has been assigned to this tensor. And we can create up to n rank tensors, but visualizing that much high order tensors it will be hard to us. So here I am creating rank 3 tensors so we can visualize it easily. So basically rank 3 tensor going to have matrix but to repeat x times. So like as matrix 1, I'm creating this first row 1 have element 1, 2, 3, 4 and 5, and second row going to have 6, 7, 8, 9, 10. Now first matrix has been created, and here I am creating second matrix 11, 12, 13, 14, and its second row going to have 16, 17, 18, 19, 20. Now its third matrix going to have 21, 22, 23, 24, 25, and third matrix going to have 26, 27, 28, 29. So you can see by seeing shape, you can see rank 3 tensor going to have 3 dimension. First dimension is showing number of times you have repeated a matrix, and matrix have dimension, and matrix shape is 2 by 5. and same second dimension is showing rows and third dimension is showing columns. And to visualize rank 3 tensor, please go through this image. Sometimes you have to perform operations on Python which cannot take tensors as a input. So you can change it to numpy array by passing it to numpy array function. You will convert tensors to array, and also you can perform directly using tensors.numpy. Here we already created tensor2 rank 2 tensors, so I have to use .numpy. Till now we have seen how to create tensors of integer and float, but you also can create complex number tensors or string tensors. If you want to perform some operation on tensors, like adding, multiplying, and matrix multiply, so we can use the add function from TensorFlow, and I'm passing here A and B tensor, which is I already created above. And if you want to simply element multiply, like 1 multiply to 1, 2 multiply to 1, and 3, this is element wise multiplication. So we have to use multiply function from TensorFlow library, and I'm passing to tensors as argument. And if you want matrix multiplication, so there is a function matrix multiplication, so you will get matrix multiplication output. Here, first one is after adding, second is multiply element wise, and third one is matrix multiplication. You can check it also, and you can do also by Python operands, like A plus B will do also tensor addition. A multiply B will do element wise multiplication, and A at B do matrix multiplication. Here you can see result are same. Some other operation, like you want to find largest value from tensors, so you can use reduce max function, and I'm passing a tensor here C, and if you want to find largest value index, so there is a function in math, it is argument max, arg max, and need to pass a tensor in it. And sometimes in neural networks you use activation function. So here is nn soft max and see. Now each output, now you can see output. First one is showing maximum element, and here in tensor C, maximum element is 10. And index of maximum element 10 is first, second row and 0th column. But indexing start from 0, so one is indicating 10, row 2 and column 0. And softmax values is here. Here it is showing softmax. Also you can convert list to tensors by using convert to tensor function. Here I am passing a list, and now this function will change the list to tensor. And all functions in TensorFlow can take parameters in form of list, and also it can take as form of NumPy array 1, 2, 3. Please same time try to read text I have written above. Sometimes your program need to extract shape, extract number of dimensions, and total number of elements automatically. So for that you can do like to check what type of data tensors hold. So for that DTYP. So rank 4 tensors dot DTYP will show you what data type this tensor holds. And to check number of dimensions rank 4 tensor have, we have to have function and dot and number of dimensions. So rank 4 tensor dot and dim will show you number of dimensions this tensor rank 4 tensors have. And to check shape, we have function shape shape. Now this line of code will print the shape of rank 4 tensor. To only extract shape of axis 0, so what we can do is to use indexing. Here I am passing 0. So it will print only rank tensor shape but of rank of axis 0. And if you want to know what is shape of last axis, so you can do -1 as indexing, -1 as index. To get to all elements a tensor hold, so there is a function tf dot size. So in output you can see tensor have float 32 data type, total number of dimension is 4. You can see here total number of dimension is 4. And shape of tensor is 3245. Element along 0 axis is 3. Element along last axis is 5. And size of this tensor, total number of element here is 120. Here it is printing as a tensor. So if you want to print just as a number, so you can do like this. Now it will return a number. And one thing to remember is TensorFlow work as a graph. So in first you will create a graph like what are calculation going to be happened, and then data going to be fed on this graph. So you must create a graph which only contain tensors in it. So if any of line which does not tensors, then it will not going to create a proper graph, and this will affect your result too. So in above we have used tensor.shape to extract shape, and this is returning only numbers, it is not returning tensors. So if you want to return shape as a tensor, so you can do is tf dot shape. Here now it is returning as a tensor, so it will work on your graph. And one is if you want to check the number of dimension, there is a rank function. So number of dimension is 4. And above we have used n dot ndim to know what is dimension, but here output is not in tensor. If you use tf.rank, the output is in form of tensors. So you can use this in graph also. Now we will see how to do indexing in tensor. Before going to indexing, I have to show what each dimension means. Like dimension 1 means batch, dimension 2 means height, dimension 3 means width, and last dimension means features. Indexing follows same rules in TensorFlow as Python do. It will start from 0, and to do backward indexing we have to pass negative indices, and to extract slices from tensors we pass columns. Let's see how to do indexing rank 1 tensor. This is the example I am going to use. To extract first element from tensor, we have to pass 0. To extract second one, we have to pass 1. Last element, as I mentioned above, we will do negative indices. So in output you can see first element is 0, which is extracted by giving 0 indices. And to extract second element, we provided rank 1 indices. To extract last element, we provided -1 indices. To extract slices from ranked 1 tensor, we will use column indices. If we want everything, we will just pass column. If we want element before 4, so we will give column 4. I'm not passing anything here because we want every element before 4. If you want to after 2 to 4, you just have to pass 2. And from 4 to the end, I'm giving for column. From 2 to 7, I'm giving 2 to 7. And one thing is, it will not extract 7th element. It will extract 7 minus 1 element. 2 to 7 minus 1 element. Every other second element, we need to pass column, and 2. And what it is meaning of this is, here I have showed this one. If we are slicing need start, stop, and step. So here I have given only step, and before that start and stop means every element I am extracting, because I am not given number to start and stop. To reverse, again I am not giving start and stop, so every element going to be accessed. But step I am giving step as -1. It means reversed, access element reversely. So in output you can see rank tensor 1 is accessed reversely. Every second element is printed, and 2 to 7 element is printed. From 4 to the end element is printed, before 4 elements, and every element. Here, to do indexing in multi-dimension, we have to pass indices for each dimension independently. In this example, I am using rank 2 tensor, which I already created above. So, if let's see, for example, I want to extract 4. So, location of this is 0 row, 1 row, and 0 column, 1 column. It means I have to pass 1, 1 dot numpy. So 4 is accessed. And if you want to access 5, location is 0 row, 1 second row, and first column. First column means zero column for if we follow Python rule to do indexing. So row and column 5 is extracted. Let's say you need second row and every column from second row. So second row and every column, and you need second column only, but from every row. So every row and second column. You want only last row, but every column. So -1, comma, every column. If you want to extract last column from first row, so I'm specifying first row, so 0 as a row and last column I'm passing -1. Skip the first row. So if you want to skip first row but to need element from others row, so for skipping first row I am giving 1 and every row every column. Here in last you can see first row is skipped, but second row and third row is extracted from and every column is extracted. We can do indexing in rank 3 tensors also. Just we have to pass every indexing for each dimension. So here dimension is 3, so I have to pass 3 indexing. Let's see, I'm going to extract each row, each example, each row, but only last column. So here you can see last column from first example is extracted 15, 20 and 25, 30. You can visualize from this image also. We can manipulate shape also. Here for showing manipulating shape, I am going to use this example. Here shape is 3, 1. And other thing is we can also extract is as a list. We can extract shape as list. So now list shape is extracted as list. Okay, coming to reshaping, we use tf dot reshape function, passing tensor as an argument and what shape we want, 1, 3. Now let's check shape of reshaped tensor. Here before reshaping it was 3, 1. After reshaping is became 1, 3. Higher dimensional tensor can be also reshaped. Like here in this example, rank 3 tensor shape is 3, 2, 5. If we want to combine all this shape into one shape or into one dimension, we have to pass -1 into tf dot reshape function. tf dot reshape function. Now in output you can see every element is combined into one dimension as shape is 30. Basically -1 is whatever shape it is, just fit it into one shape. Sometime you want to combine two adjacent shape, like rank 3 tensor shape is 3, 2 and 5. So if I want to combine 3 and 2, I have to pass 3 times 2, which is combined shape, and remaining shape is 5 into tf dot reshape function. And if we want to combine 2 and 5. I can write as 2 times 5, and also I can write -1, because it means whatever shape is left, combine those shape into one shape and keep the 3 as it is here. Now it is up to 6, 5 and 3, 10. You can visualize from this picture. Original shape of rank 3 tensor is 3, 2 and 5. One thing to remember is whenever you are reshaping tensor, keep the order as it is. As it is means what order has original dimension, original tensors. Here order is 3 to 5. You can combine those 2 and 5. You can combine 3 and 2. You can't do this combine 3 and 5 and keep 2 as it is. It will reshape, but it will completely change the meaning of tensor. So whenever you are changing order also, you use tf.transpose function instead of tf.reshape function. Like for example, I am reshaping tf.reshape into 2, 3 and 5. Here original shape was 3 to 5 and I am interchanging these two shape here in this example. It will reshape it, but element location will not change. If you want to change locations also, you have to use tf.transpose. And yeah, dot reshape into 6, 5 is also means nothing, because I am sorry, it have sense, but this one have no sense because I changed the order here also. And last example is tf dot reshape. You can only change into multiple of this shape 3, 2 and 5. You can change it to 6 into 5. You can change it to 3 into 10. You can't change into 7. You can't change to something else like 4. You have to use multiple of these numbers. Like here I am changing 7 to -1. Will not be received. What is the okay? Sorry. You can see last one is not reshaped, and it also error is showing your multiplication number is not correct. You can visualize from this picture also how 3 to 5 is reshaped into different shapes. Every TensorFlow function not work on same tensor type. Like here as square root function not take integer as input. It only take as float as input. So sometimes you have to change type also of tensors. So for changing type you can do is use tf.cast function. Like here I am creating a tensor which is going to have float 64 type. But if I want to change into float 64 type, I can pass this tensor into tf.cast function and then give that data type also dtype equal to f dot float 16. Now original tensor has float 64 type and now it is changed to float 16. And again if I want to change into uint 8 and cast it again. Here I have to use f dot and sign integer 8. Now in output you can see original type was float64. Now in last it is changed to uint 8. Element wise operation like adding two tensors or multiple tensors or multiplying will be done on tensor which have same shape, like tensor x and tensor z both have same shape, which is 1/3. So multiplication is possible. If shape is different, like this one, y tensor, if I will multiply x to y, then TensorFlow automatically broadcast y to match shape of x. And also I can do like this multipliy. This will also broadcast y to match shape of x, so they can do element wise operation easily. Here in output you can see every output is same. In this example I have created two tensors. One is column vector, another is row vector. Column vector means which have only one column, and row vector means, let me print those tensors, you will understand what is row vector and column vector. Here column vector have only column in it and row vector have only row in it. So if I want to multiply these two tensors, multiply, and multiplication is possible because TensorFlow will broadcast 3, 1, 2, 3, 4, and this second matrix also will be connected to 3, 4 tensor sheet. If let me run this code to multiply. Multiply here. Now both tensor multiplied together and result is 3/4. And true broadcasted value I have written in this example. First x was 3/1 shape, but after broadcasting it will be look like this 3/4, or same for y tensor. It will be broadcasted into 3/4 and then multiplied together, and you can compare results. Both results are seen here. And you can also broadcast by forcefully. So there is a function to broadcast a tensor into a desired shape, which is tf dot broadcast to, I am giving 3/3 here. 1 to 3 is broadcasted into 3/3. In all above examples, we have created only rectangular tensors. If you want to create a tensor like this showed in image, you can also. Let me first create this as a list: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I convert this list into a tensor, then it will give us error because, sorry, I didn't run this. Now you can see we have passed non-ranked rectangular numbers, so it can't be converted into tensors. But there is a one function which is tf dot dot constant. Yeah, now this non-rectangular tensor been created. If you want to look shape, you can. Here is 4 by none. None because column is not defined. Some row have 4 columns, some have 2, some have 3, and uh, last row have 1. So why shape of rect tensor is 4 by none. As I told above, you can build tensors of complex number and string also. So in this example, I will create a rank 0 tensors, but it will be a string. Just I have to pass a string into dot constant function. Now shape 0 and string tensor has been built. You can build the more higher rank of tensors of strings. Like here I am creating a vector or rank 1 tensor. So for this I have to give list of strings GRE revolve okay, brown fox and lazy dog. Now rank 1 tensor is created, but elements are strings. You can see in data type also. You can perform many operations on strings. You must see TensorFlow library document. I'm here only showing you a one function, which is split function. Pf dot strings dot split by space. Okay, here in output you can see rank 0 tensor is split into two component, which is I have created this in above example, which was gray wolf. Here it is combined, but now it is separated by space, right? Till now we have seen how to create rectangular tensors of rank 0 tensor shape, rank 1 tensor, and rank n tensor. Also you can create non-rectangular tensors by rank tensor function, and we can build sparse tensor also. Here to build sparse tensor like shown in this image, I have to use sparse tensor function. In this function I have to provide location. So I am giving 0, 0 of first element, and for second element is 1, 2, first row and second column. And I want values of in first location is 1 and in second location is 2. And complete shape of this sparse tensor is 3 by 4. So to print complete sparse tensor, there is a function pf dot sparse to dense. Now this will print the complete sparse tensor. So now you are capable of building tensors of any shape. You can do indexing on it. You can reshape to any shape you want. You can create non-rectangular tensors. You can create sparse, and you can do operation like reduce to max on tensors. There is one more function which is reduce to main